Welcome to this webcast of HIV This Week. I'm Kate Hankins, Chief Scientific Advisor to UNAIDS and editor of HIV This Week. Today we will explore in more depth a topic covered in issue 91, the idea of finding a cure for HIV. Before we start, let me tell you that you can find the full issue 91 at our website, hivthisweek.unaids.org. You can also use the search function on the site to find specific articles or topics that we've covered in previous issues. Now, let's talk about a cure for HIV. It was the lead topic in issue 91 for good reason. Everyone hopes to see a cure for HIV in their lifetime. We don't yet have an effective therapeutic vaccine. There are increasing numbers of people living with HIV and they need lifelong treatment. And new toxicities due to antiretroviral therapy are being seen. So, although antiretroviral treatment has increased survival and quality of life for millions of people, finding a cure for HIV is increasingly urgent, and it is being taken seriously. The call for a cure was launched in February 2011 by the President-elect of the International AIDS Society and Nobel Prize winner Françoise Barré-Sinoussi. There are currently multiple barriers to curing HIV. So, what will it take? Let's first consider the barriers. The most important barrier is the fact that HIV establishes latent or silent infection in immune cells called resting CD4 cells. In latent HIV infection, the virus enters the T cell and integrates itself into the cell's genetic code. But it does not start actively replicating itself. It just lies low with its genes turned off in the resting T cell. What this means is that it is out of reach of the immune system, and antiretroviral drugs cannot get to it either. So these latently infected cells harbor the virus for a long time. If antiretroviral therapy is stopped, these resting cells reactivate, and the result is that infection is reestablished. This is the biggest barrier to a cure. Another barrier is that low levels of viral replication occur when people are on antiretroviral therapy, even when their viral load is undetectable by conventional viral load testing. This means that there are low amounts of HIV reseeding the bloodstream. Finally, HIV hides out in what we call anatomical reservoirs, such as the brain, the gastrointestinal tract, and the genital tract. Several studies have shown that when treatment is intensified by adding on more drugs, there is little impact on these latent reservoirs. When we talk about cure, what do we mean? There are two meanings. One is the idea of a sterilizing cure. This is based on an infectious disease model, and it means total elimination of all HIV from the body. The other is the idea of a functional cure. This is based on a cancer model where there would be long-term health in the absence of treatment, accompanied perhaps by low levels of HIV in the blood. A functional cure would mean long-term control of HIV in the absence of antiretroviral therapy. Now, you may have heard about the famous Berlin HIV-positive patient who may have been cured. He had acute myeloid lymphoma and was treated twice by transplantation of stem cells from a special donor. That donor was homozygous for CCR5 delta 32 deletion. Homozygous means that both genes coded for this deletion. As a result, his or her target cells had a defective co-receptor. This means that HIV could link with the main GP120 receptor, but it could not complete docking with the co-receptor. And this blocked HIV from entering any cell. This idea is exciting, but it's not a practical approach to cure. The Berlin patient underwent pre-transplantation conditioning that included total body irradiation, which happened before each of the two transplantations. Stem cell transplantation like this carries a mortality of up to 30%. What happened for him is that donor-derived memory CD4 cells gradually replaced his own cells over a 2-year period. HIV has remained undetectable in his bloodstream and in his reservoirs. Now, it is impossible to analyze every cell in living humans, so proving viral eradication is impossible. However, given that HIV has not reappeared after 3 years without antiretroviral therapy, a sterilizing cure may well have been achieved. What other approaches for a cure are showing promise? Latently infected cells are rare, 1 in 100,000 to perhaps 1 in a million. So if we could find ways to activate them so that they would replicate, then antiretroviral therapy could take effect. Cancer therapy includes inhibitors called histone deacetylase inhibitors. They could be used to turn HIV genes on. We could also try cytokines that could activate latently infected cells. Both these approaches would not discriminate between infected and uninfected cells, so side effects would be a problem. Another idea would be gene therapy. This would use zinc finger nuclease to reduce CCR5 expression on the target cells, which would block HIV docking on those cells. These are early days to be talking about a cure, and universal access to antiretroviral treatment, prevention, care, and support is our top priority. But a cure is a prize that we need to keep our eye on. We need to carefully consider the risks and benefits for people living with HIV of each proposed approach for a cure. And that is why community engagement in this basic science, clinical science challenge is so important. There is hope that one day we will find a cure for HIV, but the road will not be an easy one. If you want to know more, then do check out these articles on our website. HIV This Week via webcast is a joint project between the Office of the Chief Scientific Advisor to UNAIDS and the Country Capacity Strengthening Team at UNAIDS in Geneva.